Okay, number 22, and this is part 6 of AP Calculus, Chapter 1, Limits. Number 22, find the limit of sine 3x over sine 8x as x tends to 0. We said that it's a formula. So directly, if the formula says if limit of sine 3x of sine ax over sine bx as x tends to 0, the answer is directly a over b. And we proved that formula, or we can prove it now if you want. So it's 3 over 8 is the answer. Let's see if what we do here. Okay, sine 3x over sine 8x. Let me go a little bit down and prove it. It's limit of sine 3x over 8x over sine 8x over sine 8x as x tends to 0, which is equal limit of as x tends to 0 of sine 3x times over sine 8x, which is sine 3x over sine 8x. Okay, let us multiply x over x, 3, 3, 8, 8, to get what? 3 by 3 we can cancel, x by x we can cancel, 8 by 8 we can cancel. We didn't do anything to the original fraction, which was sine 3x over sine 8x. Okay, can we say that it's 3 outside the limit as x tends to 0 of sine 3x over 3x, and we make this 3x tends to 0 times 8 limit, sorry, times 1 over 8, actually 8 in the denominator, limit as x tends approaches 0 of 8x over sine 8x as 8x approaches 0. If x approaches 0, then 8x approaches 0. This is formula, rule, it's 1. Limit of sine u of x over u of x as u of x tends to 0. Same here, it's the reciprocal of 1, which is also 1. What left is 3 times 1 over 8, so the answer is 3 over 8, and we can directly say it from here. Sine ax over sine bx as x tends to 0 is 3 over 8. Number 23. Limit of tangent 7x over sine 5x as x approaches 0. It's the same. It's 7 over 5. And why is that? It's limit of tangent 7x over sine 5x as x approaches 0 is equal. We can change the sign, so it's limit as x approaches 0. We can change the sign of we can change the tangent actually to sine 7x over cosine 7x times 1 over sine 5x. We leave it in the denominator, which is equal to the limit as x approaches 0, right, of sine 7x over, we'll see now, times 1 over, or leave the 1 now, sine 5x times 1 over cosine 7x. Okay, let us multiply x over x. We are not changing anything yet. And let us the first denominator fraction multiply with 7 over 7. The second 5 over 5. We leave the third and we'll see why. We can say it's 7 outside, limit of sine 7x over 7x as 7x approaches 0 times 1 over 5 outside of limit of 5x over sine 5x as x approaches 0 times as 5x approaches 0. We need it to be u as the same what we're using here. This is u of x and this is u of x times again limit as x approaches 0 of 1 over cosine 7x. We can make it 7x. We can leave it as cosine as x approaches 0 the same. What we will have, the answer will be 7. This goes to 1 times 1 over 5, because this is the reciprocal of the rule and goes also to 1, times, what is cosine 7 times 0 if we substitute 0 instead of x? 7 times 0 is 0, and cosine 0 is 1. 1 over 1, it's also 1. So the answer is directly 7 over 5, which is a over b if we have tangent also. So the answer of this is also equal to 7 over 5. Limit of sine x as x tends to infinity. This limit does not exist for sure, because there's nothing called sine infinity or equal to infinity. We don't know where is equals to, because sine x is a limited function between -1 and 1, so the limit should be not exceed these two values. Limit of sine 1 over x as x tends to infinity. This differs from number 24. Why? Because it's directly equal sine of 1 over infinity, and we all know what is sine infinity. Sine infinity is sine 1 over infinity. K over infinity is 0, and sine 0 equal to 0. Find the limit as x approaches 0 of x square sine x over 1 minus cosine square x. And this one is also very nice. Let's go down. I need more space to do it. X square sine x over 1 minus cosine square x. Okay, let us take those. Okay, we are ready. Limit limit of x square, limit of x square sine x, limit of x square sine x over 1 minus cosine square x as x approaches 0, which is equal to limit of x square sine x over, as x approaches 0, what is 1 minus cosine square x? It's sine square x, because sine square x plus cosine square x equals 0. Equal 1, sorry. This equal to limit as x approaches 0 of x square over sine x by simplifying sine x over sine x, right? Which is equal to the limit of x as x approaches 0 times the limit of x over sine x as x approaches 0. This is 1. Okay, so it is equal to 0, which is, instead of x here we substitute 0, times this one here is 1. So 0 times 1 is equal to 0. So I have 0 answer for this one. 0 answer. This one, number 27, is also nice. I think so we have space to do it here. So it's limit as x tends to 0 of, let's split these two. Instead of sine square 7x, we can say it's sine 7x, right, times sine 7x over sine 11x times sine